Cummins just dropped a bombshell that's shaking the entire trucking industry. A clean-burning natural gas engine delivering massive torque, ultra-low emissions, and fuel costs that slash diesel bills in half, all without sacrificing power. This isn't marketing hype. This is a revolution hiding in plain sight, and it changes everything you thought you knew about heavy-duty transport. Cummins' secret weapon isn't a new truck. It's the beating heart of the future, the engine itself. Don't blink. Hit like and subscribe right now because what's coming next will redefine the road forever. Engines were supposed to be the bottleneck. Everyone said it. Everyone believed it. The conversation was always about diesel, how to make it cleaner, run cooler, stretch efficiency just a little further. That was the game. That was the race. But while the world argued over filters and fuel additives, something else was happening behind the scenes. Not in public, not in press conferences. Inside a sealed, soundproof development bay in Columbus, Indiana, Cummins was building something that didn't just challenge the rules, it rewrote them. It didn't start with a breakthrough. It started with a question. Why are we still fighting the same old enemy? Emissions spikes, fuel volatility, and maintenance-heavy designs. What if the real problem wasn't the fuel source, or even its combustion process, but the way energy moves through the engine itself? That's where advanced natural gas tech came in. Not as a substitute, but as a redefinable force capable of delivering massive torque instantly without choking airflow. At first, it was theoretical. A white paper here, a small-bore test engine there. But then something snapped into place. Cummins engineers found a way to solve natural gas's biggest flaw: ignition lag under heavy load. Normally, gas engines can't deliver the same raw pull as diesel without sacrificing efficiency. But by re-engineering the combustion chamber with a proprietary high-turbulent swirl pattern and pairing it with microsecond precise injection timing, they triggered what they now call pulse torque delivery. The result? Power on demand. No delay, no fade, no airflow choke points. It was like going from manual crank to instant start, but for full load hauling. And that changed everything because now the limiting factor wasn't how far a truck could go. It was how much it could move and how fast. Diesel-like pulling power with the smoothness of a turbine. Megaload capability paired with lower total operating costs. And Cummins had it working. Not on a dyno bench, but in full-scale Class 8 rigs. Hidden in plain sight, running long-haul routes under disguised fleet paint jobs, while everyone else was still trying to tweak last decade's diesel formulas. Inside Cummins's high-torque endurance lab, the numbers were never meant to leak, but they did. What they showed wasn't just progress, it was a leap. Peak torque hitting 1,850 pound-feet at just 1,000 RPM, delivered with 90% lower nitrogen oxide emissions than EPA's 2027 standard. That's not an engine anymore. That's controlled detonation channeled through an adaptive fuel map, smart enough to read load, grade, and weather and adjust in milliseconds, and yet cool, stable, repeatable. The X15N didn't overheat under continuous hill climbs. It didn't need massive aftercoolers. In fact, its efficiency improved under heavy sustained load. Most diesel engines lose efficiency when exhaust temps rise past 450 degrees Celsius, push them harder, and wear skyrockets. The X15N thrives at peak thermal load because the combustion event is engineered for stability, not brute force ignition. That's thanks to a next-gen engine control unit running PTD, pulse torque delivery, mapping. It doesn't just meter fuel, it shapes the entire combustion sequence. Even after the equivalent of 1.5 million road miles, lab reports showed no measurable loss in output, not 1%. Same pull, same acceleration, same uptime. That's over 20 years of cross-country hauls with zero fade. And for Cummins, that wasn't a brag. It was a requirement. Because the truck this engine was going into wasn't a showpiece. It wasn't a $200,000 custom build. It was something else entirely. Cummins didn't just build a new engine, they built an entirely new class of truck around it, something the industry still refuses to believe is real. Internally, it's referred to as Project Titan. Publicly, it will launch as the Cummins X15N Prime. Price: under $140,000 for a fully spec'd Class 8 rig. Range: over 1,200 miles on a single tank of renewable natural gas. Refuel time, 5 minutes. That's not marketing hype. That's what's already been demonstrated at Cummins' closed-course proving grounds in Indiana. Full tanks in less time than it takes to grab a coffee, thanks to high-flow cryocompression stations paired with precision fuel phase stabilization. This isn't a theoretical leap, it's a practical one, and it's scalable. When select logistics CEOs were quietly invited to ride in the first pre-production Titan rigs, they weren't told what powered them. But they noticed something. This wasn't just another clean truck. This thing pulled like a freight train, 0 to 100 km/h in under 20 seconds with a full 80,000-pound load. Silent in the cab, relentless on the road. And not just once, over and over again, with no thermal fade, no injector lag, no torque drop-off. Traditional diesels lose pulling power when heat soaks the system. The X15N just kept hauling, and that's when the realization hit. This wasn't Cummins catching up. It was everyone else falling behind. Because while rival OEMs are still trying to sell $200,000 diesel rigs that burn through fuel and def like water, Cummins is preparing to flood the market with a clean-burning powerhouse that matches diesel torque, slashes fuel costs, and refuels in minutes. The shock wasn't just that Cummins built a cleaner engine. The shock was that they made it affordable. Not in the future, now. This wasn't a prototype. It was already rolling off a streamlined modular production line, vertically integrated. Every component designed for mass deployment. No exotic alloys, no overseas supply chain choke points. Just American-built efficiency wrapped in the silhouette of the most work-ready truck in history. No one was ready. Not for what came next. Because while the world obsessed over diesel bans, carbon penalties, and electric truck charging stations, Cummins looked the other way, at a fuel so overlooked, so ordinary, it was practically invisible. Not because it lacked energy, but because it was everywhere, too common to be revolutionary, until now. Natural gas. Abundant, low carbon, and easily renewable from agricultural waste streams. For decades, skeptics dismissed it for long-haul freight. Too weak, too inconsistent, too impractical. But Cummins' latest combustion system flipped that script by using an ultra-high swirl burn cycle paired with adaptive injection phasing. The X15N's cylinders didn't wear down under heavy load. They bedded in. The more it ran, the more efficient it became. Not degradation, activation. This new engine didn't just reduce diesel dependence. It erased the need for complex after-treatment systems. No DEF top-offs, no costly DPF regions, no dependence on imported fuel additives, just raw, scalable, domestically sourced power refined with AI-optimized ignition timing that self-adjusts for altitude, load, and weather in real time. But the truly disruptive twist: heat. The one thing that kills diesel efficiency unlocks natural gas performance. The hotter the X15N runs, the cleaner and more complete its combustion cycle becomes. No detonation risk, no power fade, just higher efficiency, accelerated, not suppressed by extreme operating temperatures on desert grades, in stop-and-go urban hauls, under max payload. This engine didn't just survive, it thrived. And with diesel supply chains cracking under environmental regulations and geopolitical uncertainty, this wasn't just a technical win. It was a supply chain weapon, a logistics reshuffle, a sovereign energy flex that Cummins alone seemed prepared to wield. Then came the moment no one believed, the one deal breaker every fleet manager threw in Cummins' face: refueling downtime. It was always the same excuse. Alternative fuels are great, but I don't have an hour to fill up on a schedule. And just like that, that excuse shattered. In a closed-door investor demonstration, Cummins rolled out a single X15N-powered Class 8 Titan, stripped of chrome, painted flat gray, no logos. Engineers pulled it into the bay, connected it to a standard high-flow natural gas pump, no exotic station, no experimental piping, and hit the timer. What happened next wasn't a stunt. It was a benchmark reset. 5 minutes. Not 50, not 30. 5 minutes to a full tank. The audience didn't cheer, they froze. Because the implications were seismic. No billion-dollar refueling network build-out, no decade-long rollout plan, just a redesigned fuel interface and a cryo-phase stabilization system engineered to move energy into the cylinders at maximum density without triggering heat spikes or injector stress. The secret was hidden in the transfer lines. Self-cleaning micropathways, precision-calibrated using AI-predicted flow dynamics, allowing gas to compress and stabilize before reaching the tank. No overheating, no leaks, no frost lock on couplers, just raw, uninterrupted flow absorbed with total efficiency. Post-demo surveys revealed the number that silenced every fleet skeptic. 68% of operators said their number one fear with alternative fuels was refueling downtime. That fear is now dead. But it wasn't just speed, it was stamina. Where conventional gas engines lose efficiency with wear, injector drift, valve seat erosion, combustion chamber carbon, the X15N's adaptive ignition mapping did the opposite. Each cycle recalibrated timing and air-fuel ratio with atomic precision, restoring performance like a self-healing system. Even after the equivalent of 1.5 million road miles under continuous heavy load, the engine retained 100% torque output. That's decades of service without decline. And that wasn't theory. Cummins ran the X15N under punishing real-world simulations. Urban stop-start hauling, 6% grade climbs at max gross weight, ambient temperature swings from 30 degrees C to plumb 155 degrees C, and rapid throttle load cycles designed to mimic high-stress construction site work. Not once did power taper. Not once did injector temperature exceed safe thresholds. The engine didn't just endure the stress, it thrived on it. Regenerative energy recovery also became something else entirely. Cummins's integrated kinetic-to-electric module captured braking and downhill energy, storing it in onboard ultracapacitors to assist launch torque in dense urban delivery routes. That meant up to 15% less fuel burned, not from the engine working harder, but from smartly reusing what would normally be wasted. Thermal fade, gone. No more engine derating, no more "please idle" warnings. Operators can run the X15N at continuous high load in desert heat, up mountain passes, or through stop-and-go traffic, and the torque curve stays flat. No lag, no cutbacks, no "too aggressive, try again later." Just raw, repeatable pulling power on demand. And unlike other green truck prototypes, still locked in labs or priced like experimental aircraft, this wasn't a concept. It was real. It was production-ready. It was built to work today. The fuel the trucking world once dismissed as a niche solution had just broken the rules of long-haul logistics. And Cummins was already positioning fleets to build their future around it. But building the future takes more than breakthroughs. It takes a new kind of battlefield. Cummins's revolution didn't just stop at combustion science. It found a home, a fortress in a sprawling complex deep in Oklahoma's freight corridor. This wasn't just another engine plant. This was Power Hub 1, the first production facility built exclusively for the X15N clean-burning natural gas platform. Every inch of it was optimized for speed, efficiency, and scale. Gone was the slow, waste-heavy machining cycle of traditional diesel blocks. Instead, Cummins deployed a dry-cast precision lathe process that cut water use by 90% and slashed machining time in half. In this factory, 250,000 complete engines would roll off the line every year using just a fraction of the footprint of conventional diesel plants. Vertical integration met robotic precision in a choreography directed by AI. Fully automated torque assembly lines handled 95% of production, with human technicians focused solely on precision inspection and rapid response maintenance. This wasn't just automation. It was an industrial weapon designed to outbuild every rival in the market. And the logistics, lightning fast. The first fully assembled engines left the plant within 48 hours of casting, a speed that shattered industry norms and exposed the weaknesses of competitors stuck in 4 to 6 week production cycles. This facility wasn't just making engines, it was rewriting the rules of freight mobility and energy independence. But Cummins knew one fortress wasn't enough. So they planned a swarm, a global fleet of micro-hubs embedded directly in major transport corridors. By 2026, 20 sites were already under construction in North America, Europe, and Asia. By 2028, the target is 75 microhubs, each capable of producing 100,000 X15Ns annually. This wasn't centralization. It was a decentralized production network, lean, flexible, and resistant to geopolitical choke points. Each hub was fully autonomous, guided by AI systems that synced output to real-time freight demand. This model bypassed the slow, centralized diesel supply chain and eliminated the need for long-distance engine shipping. Production was local. Costs dropped, tariffs vanished, regulatory barriers collapsed. It wasn't just a factory network, it was a living, breathing supply organism with Cummins at its core. And what does that mean when you hit the highway with 40 tons behind you? Everything. The moment you press the throttle, the pull is instant. Torque that crushes turbo lag into irrelevance. No delay, no fade, no excuses. It's raw, industrial strength power delivered with surgical precision. The X15N's torque curve stays flat under maximum payload, from the first foot off the line to the last stretch of a mountain climb. Take it into steep grades with a full load, push past slower traffic on the interstate, or snake through tight urban streets. The performance doesn't flinch. No power sag, no overheating, no hesitation. High output mode can be engaged haul after haul, shift after shift, with the cooling system shrugging off desert heat and stop-and-go abuse. Drivers testing the Titan rigs report something uncanny. The truck anticipates their moves. AI-assisted throttle mapping adjusts torque delivery before the pedal is fully depressed, syncing output to driver style, road grade, and load weight in real time. It's less like driving a machine and more like commanding a living beast, one that's always ready to push harder. This isn't just another truck. It's a revolution on 18 wheels, a preview of a future where freight is fast, clean, and unstoppable. The Cummins X15N isn't just a technical marvel, it's the beating heart of a new era in transport. And the industry is only just waking up to its power. But this power isn't locked inside a test cell. It's hauling freight across continents, cutting fuel bills in half, and rewriting the economics of long-haul trucking in real time. The new X15N from Cummins isn't just an engine for the road, it's an energy shift for the world. Delivering over 500 horsepower and up to 1,150 lb-ft of torque, it can haul the heaviest freight across the continent while emitting a fraction of the carbon. One engine can keep an entire long-haul fleet moving for weeks on renewable natural gas, hydrogen blends, or ultra-low emission fuels, cutting operating emissions by up to 90%. Cummins isn't just selling a power unit anymore. They're selling a mobile clean energy plant, a self-contained workhorse that turns every truck into a moving hub of sustainable transport. Its advanced fuel-agnostic architecture turns heavy vehicles into more than transport. They become lifelines for industries and cities. Disaster zones, remote construction projects, even off-grid communities can draw power directly from the truck's generator systems. Imagine a future where parked fleet vehicles feed clean energy into local grids during shortages, stabilize infrastructure after storms, and keep food, water, and medical supplies moving without burning a drop of diesel. The X15N's durability, efficiency, and multi-fuel flexibility make that future tangible, integrating every truck into a vast, decentralized network of clean logistics. This isn't a distant dream. It's Cummins's blueprint for a freight revolution, where engines aren't just propulsion but critical infrastructure, portable generators, constant supply lines, and modular energy units embedded in the backbone of global commerce. The implications go far beyond transport, threatening to disrupt the very fuel economy that's been locked in place for a century. For traditional diesel engines, this is the breaking point. The X15N beats its diesel counterparts on cost per mile, service intervals, and total lifecycle emissions. Against rivals like Volvo's D13TC or Scania's Super 13, it doesn't just compete, it dominates. Lower refueling costs, cleaner operations, and compatibility with both existing fueling stations and new renewable infrastructure mean fleets don't have to choose between performance and sustainability. Idling in truck stops for long diesel fills now looks outdated next to the X15N's rapid refuel times with compressed natural gas or hydrogen. Maintenance downtime drops. Fuel bills plummet. Regulations once seen as obstacles become competitive advantages. For the first time in decades, a combustion engine isn't just surviving, it's out-innovating. And beneath this shift lies the true shockwave, the death of diesel dependence. The X115N slashes operating fuel cost by up to 50% and can be paired with renewable gas contracts that lock in prices for decades, decoupling fleets from volatile oil markets. Cummins projects billions in annual fuel savings across the industry. And it's not just about economics, it's about control. Its design allows for over 80% of components to be built, serviced, and recycled locally. No oil fields in unstable regions, no geopolitical bottlenecks, no single-nation chokehold on fuel supply. The petro-diesel monopoly, entrenched for over a century, faces its first real existential threat. Micro-refueling hubs for renewable natural gas are already springing up across North America and Europe, built to feed Cummins-powered fleets. Every one of these stations chips away at the old oil supply chain, scattering its power and rewriting the rules of transport economics. The diesel age is ending, and Cummins's clean engine empire is rising in its place. This is no ordinary product launch. It's a declaration of freight independence, a warning shot in the quiet war for the future of heavy transport. The X15N isn't only an engine. It's a statement of innovation, defiance, and a new industrial order in motion. And as the smoke clears on the diesel era, only one question remains. How fast will the rest of the world switch before they're left in the exhaust?